Okay, good afternoon. It's FY here. So today we're going to learn how to decompose a rational function. Okay, when the denominator of the rational functions you can factorize. Okay, so before we go through the example, let's just look at the type of pattern that you might come across later. Okay, so the first type that you will see is we will have linear. The factor is linear. Okay, so what do we have here is you can see that this polynomial or this factor, okay, is actually having the power of 1. So this x power of 1 means that it is a linear polynomial. Okay, so when we have a linear polynomial, and because it is plus a, and we have another one is plus b. Okay, so it means that you are having two different factors. Okay, so what happens when we have two different factors? Okay, if you have two different factors, okay, let's say we have the first factor is x plus a, and the second factor that we have is x plus b. So you have to take each of the factor become the denominator for fractions. Okay, so this one, okay, we have x plus a here and we have x plus b here. So write as a form of fractions and join them with an operator of plus, of an operator of additions. Okay, so okay, once you have write out the denominator, on the top you should write the numerator. Okay, so what will be the numerator on the top? Okay, it depends on the types of the denominator that you have. Okay, so the denominator is linear for both cases. Okay, so on the top, okay, since this is power of 1, okay, so your numerator will be less 1 degree, less 1 degree than the numerator. That means that if this is linear and this will be constant, it will be constant. Okay, so why are we using a and b? Okay, because both of them are constant, but they are different numbers. They are different numbers, so I need to use different alphabet to denote the differences between them. Okay, I cannot use a here, but I have to use another alphabet. Means that we will have different number here. Okay, constant is always referred to numbers that you do not know. Right? Okay, let's just look at the second pattern that we'll come across. That is when you are having a linear factor, but the linear factor itself has has been repeated for a few times. Okay, for this case we have repeated for 3 times. Okay, so what you have to do is just write your linear factors 1, 2, and 3, and increase the power of the factor until 3. Okay, so this is power of 1. Okay, this is power of 1. Of course, I did not write the 1. Okay, this is understood as power of 1. And we have power of 2 and power of 3. Okay, so one thing that is linear because we focus on the things that is inside the bracket. Okay, inside the bracket, what we have here is x power of 1. So that's why we say it is linear. Okay, so we consider we have a linear factors that has been repeated for 3 times. Okay, so once you have identified the correct denominator, the next thing is you have to decide the numerator. Okay, since all of them are linear. Okay, so means that, okay, on the top it will be constant. So this will be constant, this will be constant, and this will be constant also. Okay, so all of them are constant. Okay, so to denote the differences, I begin with the alphabet A and until C. Okay, so let's just look at the third type. The third type, that is we have quadratic here. Why I'm saying quadratic? Because you can see that this is x power 2. X power 2, that is confirmed quadratic. Okay, when we say quadratic, okay, so you have to do the same thing. You have to split the factors and take the factors become the denominator. And in here, this quadratic, okay, and the next factor that is, this one is basically is a linear factors. This one is linear. Okay, we're trying to use the same concept. You're going to take the denominator, you're going to take the factor become the denominator. So this one is quadratic. So this quadratic will become one of the denominator of the fractions. Okay, and we have another we have the linear factor here, gx plus h. So this will become another denominator. Okay, so let's just look at whatever that we have to write on the top. Okay, on the top in here, what we have here is this one is quadratic. Okay, if you have a quadratic denominator on the top, okay, we have to use linear. You have to use linear. So it will be always 1 degree less than, okay, 1 degree less than the denominator. Okay, so this is power of 2, then this must be power of 1. So we begin with ax plus b. So this is linear. Okay, the next that we have here, this one is linear. If you have a linear denominator, on the top you will have constant. Alright, okay, so that is the third type. Okay, so the fourth type, that is you will have the quadratic, only quadratic, but this quadratic is being repeated. Okay, this quadratic has been repeated for twice. Okay, for 2 times. Okay, so that's why that we write the quadratic. Okay, write the quadratic, and we repeat it until the highest power. The highest power that we have is actually power of 2. So this is power of 1 and this is power of 2. Okay, and because of this one is this is quadratic. Okay, let me erase the rest. Sorry, this is too messy. Okay, okay. So let's look at here. Okay, since this one is a quadratic, okay, so next thing that you have to do is you have to put the linear as the numerator. So that's why we have ax plus b. This one is ax squared. So it will always be 1 degree less than the denominator. Okay, and same thing, this one is also a quadratic. When you are also having a quadratic, okay, you are having a quadratic, on the top you will have linear equations. But of course, we will write back ax plus b because we want to make a different. We want to make a different from the previous fractions. So that's why we start from c. So we continue the alphabet basically. Okay, so we have cx plus b. Okay, why don't we look at the example directly? Maybe you will understand more regard this. Okay, so let's just look at the example 8a. Okay, so for example 8a, so we have 13. Okay, for example A, the question is actually asks you to decompose the function, okay, without solving. We do not want to solve. In this case, we just want to know how to decompose a function correctly. So in here, okay, you may factor out whatever at the bottom, and this one is you can factor out by using your calculator. At the bottom that you will get that is x minus 3 and x plus 2 here. Okay, so when we focus on the factors, what we have here is you will see that inside a bracket, the highest power that you can see is power of 1. So that's why we say that it is, okay, they are actually linear. They are actually linear. So this is linear and this is linear. But because they having this one is x minus 3, this is x plus 2, so we say that both of them are having different factors. Because you have different number at the back. Alright, okay, so you have different factors. Okay, so basically it's fall into type number 1. So you have linear and you have different factors. So what you have to do is just split the factors. Okay, you have x plus 3, and okay, you have to join them with a plus. Okay, so you have x plus 2 here, so you have two denominator, okay, with different factors. Okay, and then on the top you just have to write this one is linear because it's linear, so on the top must be constant, so this must be a. Okay, and this is linear also, and on the top must be constant. We cannot use a anymore because it has been used in here, so it will be b. Alright, okay, let's just look at this one sequence also. Okay, let's just look at the b. Okay, the b that we have here is 3x squared plus 5x minus 10. We have this. Okay, so what we have here is we have two different factors. Okay, so one is x minus 1 and the one is x plus 2. So basically they are different factors. Okay, but okay, we have a factor which has been repeated for 2 times. Okay, so let's just analyze whatever is inside the bracket first, and this is linear and this is linear, and but this linear factor has been repeated for twice. Okay, so this is repeated factors. Okay, so when you have repeated factors, what we can do, okay, first of all, just split each of the factor become one denominator. So in here you will have this one is x minus 1, it's coming from here. Okay, and then you have to join with the plus, and we have the another factor. Okay, another factor which is x plus 2, okay, and the x plus 2 you have to write it until the highest power that you see in the questions is power 1 and this power 2. Okay, so that is for the factor of x plus 2. Okay, so we're going to repeat until you see the highest power. Okay, and then okay, so let's just decide what should we write on the top. Okay, on the top you should write that this is actually a, okay, because it's a linear. Okay, and then this must be b, and another constant because it's also linear. Okay, and this is also considered linear. Then will we continue to the alphabet C. Okay, so let's just look at part C. Alright, example C. Okay, let's just look at the example C that we have here. Alright, okay. So what we have here is we have a linear, and we have a quadratic. Okay, so same concept, we're going to use the same concept. So each of the factor become one of the denominator for each fraction. So we will have the first, this one, and you have join with another fractions, and this become the denominator also. So we have x squared plus 4. Okay, so once you have that, okay, then you have to decide what to put on the top become the numerator. Okay, so in here what we have here is you have a linear, so on the top that you should have a constant, so we should begin with a. Alright, so it's a constant. Alright, okay, for this one is a quadratic basically. So you have different factors, another different factor that is quadratic, and on the top it should be linear. But we have to convert the alphabet. Okay, this one we have used the constant a. Okay, we have used the alphabet a for the constant. Then we have to continue with the alphabet b. So we have b x plus c. So this is linear. So basically you can see that okay, it is x power 2. It is quadratic as a denominator. Okay, at the top we will have linear. right? We will have linear that is x power 1. Okay, so let's look at the example D. So we have this. Alright, okay, so same thing. What we have here is we have different factors. One is linear, another one is quadratic, but this quadratic basically has been repeated for twice. Okay, so this is repeated. Okay, so we are having repeated factors. Okay, we have repeated factors in here. So same thing, I would write this one as one of the denominator, and I would write this one become another denominator. But I have to write this denominator one more time because the highest power that I can see for the quadratic that is square, that is power of 2. So means that I have to write it again, and this until the highest power that you can see this power of 2. Okay, so this power of 1, this power of 2. Alright, so once we have written the numerator, the next thing is we have to decide the numerator. Okay, so the numerator, this one, okay, because this is linear, so on the top it should be constant. So constant, we begin with alphabet A, so this constant. Okay, this one is a quadratic. So when you have a quadratic on the top, when you have the quadratic at the bottom, so on the top it will be the linear. So since we have used the A, so we should go for B. It is bx plus c. Alright, so this is a linear. Alright, okay, and we have another quadratic here. And then it should be linear on the top also, and we have to continue the alphabet. So this C, then we start with D. So this bx plus c. Okay, let's just look at the last example. Okay, let's just look at the last example. Which is our E here. So we have x over 2, and we have x cubed, x minus 1. Alright, okay. So, okay, for this case, you will have two different way to decompose this rational function. You will have two different ways. Okay, let us see how to decompose. Okay, let us look at the first option that we may have. Okay, so I will write it out, this one again. Alright, okay, the first option is you consider this x cubed as linear. Okay, why I'm saying linear? Okay, just have to consider this one as a linear function, which is x power of 1, but it has been repeated for 3 times. It has been repeated for 3 times. Okay, consider it as that way. Okay, and we have another one. Of course, this one we have no argument. This must be linear. This must be linear. Okay, let us see what happens if we consider x power 3 as the linear factors. So what you have to do is, since this is linear, so you have to write x, and then x power 2, and until x power 3. Alright, because we are considering this one as linear factor, linear factors. The power of the linear factors is power of 1. But okay, these linear factors has been repeated for 3 times, so we begin with power 1, power 2, and power of 3. Alright, okay. Then last, it will be x minus 1 only. Okay, so let's just look at whatever that we should write on the top. Okay, but since that we say these three are the linear factors. So as I said just now, if they are linear factors, means that on the top it should be constant. So this is constant, and this is constant, because we consider each of them is linear. All right. Okay, and this one is another linear, so we have D here, right? So this is one of the options that you can think of to write the decompositions of the rational function. Okay, so let's just look at the option 2. Okay, so instead of considering the x power 3 as linear, so we consider the x power 3 as cubic directly. Alright, of course the next will be linear. This will be linear. Okay, then okay, this cubic will become the denominator of one of the fraction. Okay, and this will be another fraction. This is x minus 1. Okay, because we are having a cubic as denominator, means that on the top we will have the quadratic as numerator. We will have quadratic as numerator, and this one quadratic will be begin with power of 2x power 2. So let's begin with ax squared plus bx plus c. Alright, okay, and in here, because this is a linear, so since this is a linear, so on the top it will be a constant. Okay, constant, but the constant should continue the alphabet from the previous, and this must be D. This constant. Okay, so basically that is the general idea how to decompose a rational function. Okay, and of course we will come across some variations of the question, but the basic idea of doing that is roughly here. Okay, and and for this question, because we have two options, I would say that the option 1, even though it means it look like a bit it looks like a bit tedious as compared to option 2, but I would say that option 1 is a better option. It's a better option because later when we solve the problem, okay, the step of solving will be shorter as compared to the option 2. Okay, so option 1 will be a better options when you have two different ways to solve. Okay, and this one is a better one. Okay, see you next class.